Hi, I was just discussing with my student. It's not a session or something. We are just having a casual discussion in Google Hangouts. He sent that he is getting some job openings and calls for different openings, and this is more about kernel development, and we do had sessions in the past on kernel topics, and then somewhere I mentioned probably this week or sometime we can have when we have the session we discuss about some roadmap, okay, because this is where he's getting a lot of openings on device drivers or some type of kernel development and stuff, and he's yet to get much deeper into that, and I thought let me have a more serious discussion about it and give him a proper schedule and a roadmap. But again I thought this is again frequently many gets confused. I do get a lot of mails, and I thought let me take a video anyway. Anytime I get any mail like this, I can just suggest this video. Perhaps it may help you as well. See, many mention that or send emails or even YouTube comments that they are interested in getting into kernel development, or they are interested into learning Linux. When they vaguely say learning Linux, I have no idea what they meant, because that even means you may be interested working in Linux software development. It can be just user space, okay, so kernel space is altogether completely different. So I do get emails. I thought let me give a precise 4 to 5 points so that you can start off work on these areas. Either you can do yourself, of course you get every information free, or in case if you are interested, of course you can join the classes as well. Like I mention always, see, the classes, the main intent of anyone who joins with me is not about you learn something new and completely different, okay. You get these days, just think practically, you get these days whatever you want to learn absolutely free almost. You can Google anywhere in the internet. You can buy any Linux books or download any Linux books. Some are free books are available as well, like Linux kernel internals and Linux device drivers or whatever, okay, Linux insights, and there are so many books are there like that. So you can get any of these books, and apart from that, any online stuff, of course YouTube videos, not just my channel, any other channels, okay, you can self-learn. But the point is the point about joining with me is more or less what you are learning is some lifestyle. That's the main objective. I may teach my way of doing things. Perhaps it may help you to connect the things, and it may help you to get on board the way I approach. So the most important criteria is you are learning most of the times. I mean, they are learning most of the times who are my students is it's just a way of life. I show an example so that perhaps they can take this as an inspiration in those sections. See, I do discuss same in videos also, but it will be much deeper, and it depends. They may ask a question and we may entirely discuss about it in an entire 1 or 2 hour session, who knows, okay. So eventually their learning is just a way of approach and my way of doing things. So more or less it's like, so let me give some few pointers quickly so that work on these things, do by yourself, or maybe you can join a course, you can join anywhere, that doesn't matter, but just work on these things so that you can understand this. You finish, after that this you finish, and then slowly you are now ready for something like that. See, when you want to work in kernel space or device drivers or any Linux stuff, okay, what primarily I see the mistake is someone who is still a beginner in C, they just see some job portal, they just see some openings and then they decide. So this is something ideally I don't much recommend. You need need to be first, see, most of the kernel code is written in C for an obvious reason, and apart from that it has also bits of assembly and stuff. It depends which extent you want to be a developer in Linux kernel software development. It is just the platform stuff, or device drivers, or some kind of technological aspects like storage, networking and stuff. See, this is, of course, I do mentioned discussed in the previous episode. So be open. If you are a beginner, the most important criteria is you should be good in coding. I'm not saying that you should be good in only C coding. You should be good in any type of writing a logic. Okay, what I meant good in coding is not that you should be good in some C pointers. You should be good in some C data structures. What I say data structures is not the college definition of data structures, like you have linked list, tree, arrays, and stuff like that. I'm not saying these data structures. I'm saying is you should be good in the overall aspect of, you have the data structures which you may have when it comes to C. You have the structs and then the associated APIs and stuff. See, here is where I'm saying you be good in programming, in the sense it's not about solving puzzles, it's not about answering some type of interview sort of questions. Be good in programming. If any given task, you should able to code, and you should able to program that logic. Okay, it's not some kind of sample code or something. You should be very good in programming. That's the first criteria, even before you think about getting into kernel. So if you don't understand, what happens is you get mess around, you learn in some institute or somewhere cram course, you will be not equipped to do any sort of work. So first thing is be good in programming. What I meant is not solving puzzles, not solving that pointer questions in C. What I meant is be good in programming in terms of writing real serious code which can span up to around 1000 to 2000 lines of code comfortably, done all by yourself in most cases. So be very good in programming, let it be in user space, whatever it is. Okay, be good in programming. If you have some experience in scripting or something, yes, it is an added advantage, because eventually the most important criteria is you should be good in coding. It's not about solving some discrete puzzles and then prove that you know everything. It is not. If you are not good in programming, you can just forget about going to further steps. So the second thing is so that's the first thing. The second thing is, the next thing is, if you have little learnt Java and C++ in college, okay, use that approach to learn the kernel code as well. Okay, what I meant is, when you study object-oriented programming, you have these objects, and then it's you have the classes and its instances, or you have the objects and stuff. So what happens is, you have the classes which are the template. The classes contains several classes within the class, or it may contain variables of that class. So a fruit, you have a fruit, then it may have several variables describing what that fruit is, and then you have the controlling member APIs also. Some are private APIs, some are public functions, private functions or public functions, or you call it as an API. So you have private and public APIs. Okay, so usually I seen often any system developer don't use the word APIs. I seen often web developers use, or application developers use this word API quite often. So learn the word API. So don't call as functions, don't call as some you have this functions and procedures and all. Just use the word, be practical, use the term which is used in industry, don't use the term which is used in college. Okay, so use the term API. API means it's an application programming interface, which means any task you do, it's been abstracted and there is a function available, so you just call that function. For instance, you have the printf, you don't need to do some write and all that system call. Instead, what you can do is you can use that API which is provided in the glibc library. So same way you have memcopy, strcpy and stuff. So same way in the kernel, learn various data structures. See, this is the problem with C developers is, See, we go into any example like this. See, we go to Linux and then we go to schedule, where you will get the task struct or something like that. Okay, we search for yes, schedule. You will find this thing. You will find this task.h or something, and you will find a specific API. For example, task struct, we search where this is. See, this is in include linux schedule.h, right? So you go there and you have the data structure, struct task. As you see here, the one mistake C developers do is they don't learn in a more optimized way when they read the code. Okay, so read sections of such code in the kernel of various kernel subsystems. One is memory, one is process, one is drivers and stuff, one is networking, one is file system, and so on. So there are various subsystems in any operating system's kernel. Okay, so when you read about OS, just read about all this introduction part. Don't jump into some kernel programming and don't fool yourself. It is never going to keep you, it's never going to get you on the board. Okay, so one thing is learn the data structures. The data structures are problematic when it comes to C programming because you have the struct separate and API separate. So learn what it corresponds. Okay, see, this is the struct, and if you scroll down, you should get its related APIs, right? So see, you have an API, it takes this task struct. You have an API, it takes this task struct. The problem with C code is you have the discrete approach. You have the struct in one place, APIs in one place, versus if you write in object-oriented code, many Java developers, already, in Java we use any class. Once you know the class, you know how to use it. Okay, because the class has certain APIs. There are constructor, destructors. You know that constructor does this init part, destructor does that uninit part. It will do any cleanup and stuff like that. So you have this class APIs, right? Some are private, public. So you learn what it contains, what are these APIs, especially public APIs, because those are the ones which you use. Private ones are like equivalent to static APIs of C code. So those you should know this thing. In the case of C, the big problem is it is not bound together. See, in the case of object oriented, right, you have this class foo, and right after that, let's suppose this is C++, so right after that you get this variables, and then you have this public functions and private function, instant function 1 and something. So this is public, private, whatever it is, and then it is bound inside this class definition, right? See, it is bound inside this class definition. But when it comes to C, unfortunately what is happening is you have this struct. Let me change its color. Struct foo, and then you have this struct completed here. After that you have discrete APIs, right? What happens is int function 1, and this will take usually struct foo, some pointer instance it will take, struct foo of foo, something like that, and it is going to take extra arguments. See, you see here there is no connection between this and this, versus in the case of object oriented, this is connected, this bracket is connected to this bracket is connected to this, versus here this is the data structure stops and you have the discrete variable. So don't fool yourself, learn what is the data structure. What I meant is data structure is this container type of data structure, which is, these are called as container data structure. It is just going to hold something related to that object. So although we don't have objects in C, imagine there are objects represented in this struct and APIs way, which is unlike object oriented, which is why again I'm saying I said in a few videos I don't much like C++ nor objects concepts, because the same what you do there, you do exactly the same you can do in C itself. So having said, understand this, if you are writing kernel code, just spend some time, go through different data structures and respective APIs of different kernel subsystems. Let it be memory, process, and stuff like that. See, this task struct is the data structure. Every time you do ps minus aef and ps, let me type just ps, right? See, you can see there PID, whatever it is, that PID is actually coming from this data structure member variable. See, somewhere if you scroll, you should able to find PID. Yeah, see there, this is PID and it is coming from this task struct. So it is nothing but every time there is any instance, see, each process is just an instance, okay? There is no much of hangama to do. This is the problem. What happens is, in the books they make huge fuss, and in the college they again teach you because they just don't have any real exposure, so they given some type of explanation which makes you ready to write exams. But when it comes to the industry, you are supposed to write the real working code, okay? You can't escape writing the real part, not just learning something in logical theoretical aspects. So what happens is, in the real part, what is happening, every time you do ps command, it is showing all this process. What is a process? It's just an instance of this data structure, okay? So when you kill the process, when you do some activity on that process, let's suppose you change the priority of that, whatever you do, bloody, you are changing the data structure contents of this task track, okay? If you change the priority, there is an API which will change the priority of this data structure. Some variable will be there and it will change the priority. That's all it is. See, you can see there priority, there are many aspects. See, this priority, and that is what it is actually going to change. So if I change for example, I have this color paint, I can do renice minus 20, and then I can give that PID something like that, and it is going to change the priority, right? So I need to do sudo, and if I do that, you can see there it has changed from priority 0. So which means actually it is changing the priority. And if you go down, there is some kernel API, it is doing it. And most probably you should also understand, in kernel code you don't need to write any new code first and foremost, unless you need to do some new hardware device driver. So 99% of the time you don't need to add any extra code. When you want to be a kernel developer, you will be keep adding code. It is not. Most probably you will be doing some maintenance part. There is a lot of code which needs to be cleaned periodically. This is why companies do recruit kernel developers, so that they can maintain their forked kernels which they use for appliances, okay? This is the job you are going to do. So take out of your mind, write a new module and this is what is kernel program. This is bullshit. You will work in existing kernel code most of the times. If this has any bug, most of the times you will fix. Yes, it is bug fixing work and it is not an exciting work, and this is the reason I don't do this work for. But if you want to be a kernel developer, this is something you need to do. Versus I'm a kernel developer, I become a kernel developer, I just need to add my software into the kernel space. So I learned the networking subsystem, and I fiddled around, and then I was able to successfully add it in the kernel space. In the process I learned a lot how the whole thing works, and stuff like that. So this is my learning curve, okay? So my intent is to add my code which is traffic squeezer. I need to put it in the kernel space. So my intent is different, but I have not worked in any company just like that as a kernel developer. So my intent is completely different. My intent is business driven. It's a business decision. When I had my company, I had my code in user space, I want to push it in the kernel space. So in the process I have to do several things, and I have been able to push my code into the kernel space. So that is why I'm saying most of the times you may not add new code. So the point number 2, let me summarize. The first thing is, be a good programmer and be a good in C programming, and understand the big picture of C programming, not solving some puzzles or some pointer questions. You should be good in writing code, okay? The second thing is, learn the data structures. What I meant data structures is not tree, linked list, all this bullshit which you taught in college. Learn the kernel data structures, which is all the structs and its associated APIs. When I meant data structures, which means these two together, okay, not this, struct and call it yourself as data structure. Okay, what I meant a data structure is this. Okay, you have an struct, what to do with that struct, using those APIs, how to do any changes to that data structure. So learn this part. Okay, the third thing is learn different subsystems. Okay, again we need to go back we need to go back to its roots. Your objective is to add stuff in the operating system. The core of the operating system is the kernel itself. Learn about the kernel, learn about various subsystems much deeper, and when you read different subsystem, learn their corresponding data structures. So stuff like that. So you can swap the point number 2 and 3 in any order. You can first do is 1, be good in 1, which is programming. Then you can learn OS and fundamentals, of course, and then various subsystems, and then you can read the Linux kernel source, because when you read the Linux kernel source, it's no longer a theory. When you read any operating system book, it is stories. When you read the Linux kernel code, it is not a story, it's a real implementation. Sometimes what they define in the book will not be done the same way in Linux kernel, because it's a real working kernel. You can do changes, you can put exceptions and do your own changes. So definitely you can find it in the kernel code. Sometimes what is defined in the fundamental OS stuff will not be followed as it is in the Linux kernel. So you can swap, either you be good in data structures, learn this way, or else first learn various modules and then come to various data structures you can visit. So the next point is when you are good at all these three, then you can go much deeper, take a specific module, do a code walk, a proper code walk of different interesting modules which it interests you as per your priority. Okay, so that you can do that. And finally is writing any new modules. You can start slowly writing any sample modules. You can download from internet, write it, first compile it and make it work. The big problem is compiling some of these online examples or samples itself is a challenge, because they have done it for a different kernel. You can't simply compile it in your version of working kernel. So you need to sometimes port maybe just an extra argument or something you need to do. So here itself there is a lot of learning curve is there, and then slowly eventually you will be good in writing your own kernel modules. Okay, so this way, or writing your own kernel sources. So this way, I'm summarizing. The steps are very simple. Okay, let me just summarize. Right, let me open a new window. It's very, 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 very simple. See, first, good in programming. Okay, the second, and as well you can flip-flop between 2 and 3, where order you are. Okay, the OS concepts, and learn Linux kernel and its modules or subsystems. The third is the data structures, and what I meant is the struct and APIs. Okay, what I don't mean is not a tree, linked list, all this bullshit. Okay, what I meant is the struct and API. That is what constitute for me a data structure when I think about kernel coding. Okay, so the next part is you can do is the data structures are over, APIs are over, and then you can go through a deeper code walk of different modules or subsystems. Okay, see, when I mention modules, don't confuse as kernel modules. When I mention modules, I mean to say the whole subsystem. You may be reading about some writing kernel module. I don't mean this kernel module sample something. If you see, you will find a hell a lot of documentation like this. I don't mean a module is this. Okay, see, you go there and they will be writing a hello world stuff. you see their module in it, stuff like that. I don't mean this. What I meant is the huge of that, the whole subsystem, let it be whole networking. In that there are various modules in that. So I meant that. Okay, so do a deeper code walk of different modules as per your priority. See, if you are interested, go through the memory part, if you are interested, or process part, or any other subsystems as it interests you, right? So you need to do that. Okay, this gives a proper picture that what is existing, and stuff like that. So this gives a lot of idea that what is there in the kernel itself. So you need to spend a lot of time to know that what is there in the existing kernel, rather than start from day one thinking about adding new code. I don't know why some people teach like this in institutes. Okay, you should know what is there in the existing kernel than adding new code. So in the end you can start writing sample code, and you can have write new modules or change existing kernel code. In case if you find any bugs, in fact you can submit to the Linux kernel foundation and stuff. There are various steps available. You can go through, and you can submit your changes to the kernel the mainline kernel as well. So if you are interested, you can do that. So this is what somewhat you can start your journey. I don't see any other way you can actually achieve if you don't have this type of roadmap and discipline. Of course, I'm going to discuss the same with my student, but more than that I may discuss several other things, because I know what he knows, I know his background, where he's coming from and stuff like that. So which is what I thought. But again, I thought this is a FAQ. Many get confused, and let me just quickly summarize. Of course, this video, like my all videos, is long, but it is a quick summary of what you are supposed to do. Okay, good in programming, OS concepts, learn Linux and its modules and subsystems, because the OS concepts is a theoretical stuff. So one can say this is a banana, but you know in the world there are various breeds are there. So there are various species of any animal is there. So naturally, what is the thing is, you can't just define a cat is this or a dog is this. What is this type of dog is? So it is this breed, it eats like this, it sleeps like this, it lives like this, is different than a different breed of dog. So same way, Linux is one implementation of an operating system. So as you know the OS basics, you can know about the Linux part, and then go deeper in various modules, or when I say modules, it's subsystems. Then learn the data structure. The most important thing is learn data structure, because you want to be now a programmer of it. So learn the data structures. So let me highlight the most important things are this, focus more, this, focus more. Okay, and then eventually the other things comes. So when you focus these two, eventually you can do this. When you don't have programming skills, just solving puzzles is not going to help you anywhere. You may be solving a puzzle, how this line of code works is of no use. You need to know in a big picture how the overall thing works. So get this, and this is the tricky part, which is why I'm kind of highlighting. This is the most tricky part. So try to get over it, because like I said, you are not going to learn like our JavaScript, Java, or the object oriented in C++. In C it is spread across. So since kernel is written mostly in C and parts in assembly, focus more on this. Learn, as you more learn the data structures, you will know how to use that. Okay, using this data structure. So I can in a way I can compare before I conclude is, here you are learning some alphabets. So you are just learning some alphabets, A, B, C, D, and here you are learning some vocabulary. So what is a cat, what is a dog, how it is called, and stuff like that. Okay, so you are learning something like this, and here you are learning, in this whole process you are learning is grammar. Okay, and then in the end your objective is to become some type of an author or a poet and stuff like that, right? So poet and stuff like that. So whether you will become an author or poet is still a question, because programming I consider is an art. I don't say that you do this, learn this, and you will become a great programmer. You can never become a great programmer. Maybe you can become an average programmer in most cases. Some with the proper dedication and proper understanding may perhaps get in much deeper level, but in average, if you want to become an average programmer, still you should have these things, right? Which is why I'm saying, just learning grammar, just by knowing English very well, you can never be an author, you will never become a poet or some movie director, right? You will never become some kind of Hollywood. Okay, so that takes a lot of creativity, which is the same you need when you write code also, which is why I'm again saying you should be good in programming. So this is nothing but you should be good in programming. If you are good in programming, then you will be good in this. So if you are good in movie making, okay, given a mobile phone or given any iPhone or DSLR or anything, even without Arri or movie camera, okay, you can still shoot a good scene with this low-tech device. And same thing you can upgrade when you have a full high-tech device. You will be doing in a much professional way the outcome and the results the way you want. So you can become a movie director only if you have the knowledge of how creatively you take that scene. Okay, so which is why I'm saying this is the most important thing, and rest it follows. And if you don't have any good programming knowledge, you are still a beginner out of college, something you are claiming that you are still learning something in this, you can forget about this. Why do you need to go into this which you don't know? This way you should unnecessarily waste your time in learning Linux kernel, which is why I'm saying I don't want to give some type of crash course or something. Even anybody who joins with me, I want to give is the reality. If you don't get here, it's just no point trying to get into this. It's just a waste of time. You will go there and it will be looking more complicated, and you will eventually think it is kind of more bigger than what you expected, and you will lose interest eventually. So just follow this, be good in programming and follow these steps. Okay, so hope this gives a perspective, and like I said, I just want to give a very quick point-to-point roadmap and a summary. More or less I want to discuss the same with my student as well when we have the proper session, upcoming session this week and something. But one thing is, I know his current skills. He is not some newcomer. He is not some student right out of college. He have a very good professional experience. He is a very good developer as well in embedded and stuff. But the things which he wants to improve is areas like that. So I want to discuss in a much mature way, because he is a guy who is in the industry for several years. So but more or less this is going to be applicable. See, for him, he's not there is no problem about good in programming. He is already good in programming. OS concepts he vaguely knows. Data structures he need to improve further, and here he need to improve even more further. See, for him, lot more things are addressed already. From here to here he need to improve further. Okay, but if any random viewer watching these videos, obviously I don't know, you may be just a student, or you may be having a decade of industry experience, never worked in kernel, but in most of the user space kernel software and stuff like that. So it depends on what is the skill level you have, but the flow is the same. If you are very good in programming, been in the industry for some time, then the point number one is not an issue, but the other things still apply. How you need to approach like you write a Java code or OOPS code, get a hold of all these data structures of different subsystems. And since kernel is huge, you need to just go through different subsystems. It takes time. Anyone who says become a kernel device driver developer in a month is just foolishness. It is, you cannot. You have several things. It may take 6 months or even 1 year also, but you should have that consistent passion to learn all these aspects. Okay, so hope this gives the big picture and the perspective, and just follow this roadmap. Like I said, you do by yourself, or you join under anyone, or not just me, just join under anyone. Just follow this roadmap. Eventually you will become what is there actually, but focus on the creative aspect rather than the dumb solving puzzles and stuff. You have to make if you want to be a good director or you want to become like A.R. Rahman, you should be good in making music rather than you do with a expensive keyboard Casio versus Yamaha or some Roland or something like that, Korg or something. Rather than that, you can just do in anything. Any instrument is fine, flute, whatever it is. You can even whistle and you can create. But the main thing is creating music, not the instrument. So have this, perspective. Okay, don't get carried away with solving puzzles or something is not going to take you anywhere. So be good in programming and then you can follow this. So hope you enjoyed this episode and this session. If you have anything to discuss, be in touch via mail, or if it is a small query, you can post it in YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.